Hi, my name is Valerie Palomares. Um, if I sound weird, it's because I am sick and I'm getting those better. Anyway, this is my oral presentation about the water cycle. The reason why I chose this presentation or this topic is because I want to become a future educator for early childhood, and I think it's very important to just go more into detail about the water cycle, especially when it comes to collection, runoff, and infiltration, because those are not the ones that are most talked about. Also, we are going to do a brief summary of the articles found in China, which are studying the summer anomalies, um, the moisture of the three major rivers, and climate warming. So, introduction. This introduction is just, like I said, going more into detail about the water cycle, about each of the process, and sorry, and just talking about in China, the researchers studying what I had mentioned. So, the water cycle consisting of evaporation, transpiration, condensation, and precipitation is essential for regulating Earth's climate and water distribution, with evaporation playing a particularly critical role in regions with abundant rainfall or high temperatures in China. In China, summer anomalies highlight the importance of condensation and precipitation, especially in relation to the moisture dynamic of the three major rivers. Climate warming intensifies evaporation, which fuels subsequent precipitation, linking atmospheric processes to geographic variations and water availability by examining hydrochemistry across northern, oh, sorry, by examining hydrochemistry across northern and southern basin, researchers can better understand how the steps of the water cycle interact with regional environments and contribute to border climatic patterns. And then on the side, we just have more of like a context what we're going to be talking about or the slides. Basics of the water cycle. The water cycle consists of four steps: evaporation, transpiration, condensation, and precipitation. In detail, the water cycle is a continuous movement of water on, above, and below the Earth's surface through the process of the four steps. The water cycle goes through the three states of matter: solid, liquid, and gas, because it goes from liquid to gas, also known as evaporation, and back to liquid or even solid, which is ice, equals precipitation. The water cycle is very important to the environment because it regulates the Earth's temperature. Aside from the four steps that are commonly known, there is also collection, runoff, and infiltration. Infiltration is similar to groundwater. And we're going to go into details about each of the steps. So, yes. Listed below are the steps of the water cycle in order in which they occur. Okay. Evaporation. The sun heats up the surface water in the ocean, the surface water in oceans, lakes, and rivers, turning into water vapor. The water vapor or gas rises into the atmosphere. Um, Transpiration. Like evaporation, but instead of water, it comes from plants. So the plants release water vapor into the atmosphere through their leaves. Condensation. As the water vapor rises, it cools and changes back into small, tiny liquid water droplets, moisture, or ice crystals, depending on the temperature, which lead into forming clouds. Precipitation. Once the clouds become saturated, the water falls back to Earth as rain, snow, sleet, or hail. collection. All the water gathers in oceans, lakes, rivers, and or and underground groundwater, which flows back into larger bodies of water. Remaining water that did not soak into the ground flows over the land and into streams, rivers, and eventually the ocean. Infiltration. Some water soak into ground, which is another word for groundwater. And then here is just a quick picture of the water cycle. You can see where the evaporation goes up. You can see where the evaporation goes up to the sun. Mhm. And then you also have evapor evapotranspiration, which is the same as transpiration. Um, and then you just see going up. Condensation is where the clouds are at. Precipitation goes down. Snow melt runoff. And then down here we have the groundwater recharge and flow, discharge and flow. Um, yeah, you can see everything here, river discharge, um, ice and snow and glacier. Pretty much this is more into detailed about the water cycle. So evaporation. Evaporation is the first step of the cycle along with transpiration. The way evaporation occurs is by the sun that heats up the surface of water, which leads to water vapor. So the water moves from the Earth's surface to the atmosphere. The heat forces the bonds that hold the molecules to break apart. Because the Earth's surface is dominated by oceans, they are the primary source of atmospheric water, sorry, with solar heat driving evaporation that leaves salt behind and lifts fresh water into the air to form clouds. Evaporation occurs globally wherever heat is present, making it more widespread than precipitation, which is less frequent in certain regions. Geologically, evaporation and precipitations balance each other overall. Sorry, though they vary locally. Evaporation is the most critical step in the water cycle, ensuring that oceans remain replenished through runoff and groundwater discharge and sustaining the continuous movement of water the plant across the planet. So the way you can see evaporation in real life is that you boil some water and you can see just this water vapor going up. That's how you know the water is evaporating because of the heat. Evaporation has a cooling process. After gathering enough water into the atmosphere, it starts a cooling process to prevent getting more water vapor, and it is noticeable in areas where humidity is low and temperature are hot. Areas that get the most evaporative coolers are dry areas in the United States, such as the west side of the state. So pretty much what this shows is that in Area A, the evaporative coolers are effective in the United States. Area A are located where the states have dry areas. You can see it going up from here to over here. Evaporative coolers can also work in Area B. Area C is more humid, so after gathering enough water into the atmosphere, the cooling process happens less often compared to Area A and B. Sorry. Transpiration. Transpiration is like evaporation, but it is different because instead of oceans and water, it uses water from the plants. Transpiration is where the plants absorb water through their roots and release the water as the water vapor into the atmosphere through small pores in their leaves, also known as stomata. It contributes to moisture in the atmosphere, giving it almost 10%, where evaporation handles 90%, such as oceans and lakes. The process releases moisture, which contributes to the water cycle. Roots draw nutrients along with water. This supports plant growth while cycling water back into the air. Some of sorry, some of the absorbed water is retained for plant functions while the rest are released into the environment. Um, Transpiration usually varies because it depends on weather conditions, so it will affect the process. Cacti and succulents, they have water inside, so they don't really have to release anything. Or if they do, they release like a really small amount of the transpiration. Soil types, clay and sand. Um, the clay, I'm sorry, the clay particles are small, so the clay type can affect the transpiration process. It holds the water, and the sand particles are bigger, so they let go of the water rapidly. Sun availability, some plants have really small amount of sunlight, so they rarely get any sun. And there are plants that get a lot of sun, which affects with the water vapor because they're getting a lot of sun, but um, they're not getting enough water back. So it damages the plants. And then here you can see how it's working: evaporation, transpiration, and precipitation. Sorry, condensation. The second process of the water cycle is condensation. After the heat evaporates the water from the ocean or lakes, the water vapor in the atmosphere cools down and changes into water droplets which form into clouds. Once the water vapor cools down, it condenses into dust or small particles to form small droplets or ice crystals, and they are all gathered into the clouds. When the droplets become too heavy, they come down as rain or ice, also known as precipitation. Sorry. Condensation is like the three states of matter: liquid to gas, then liquid or solid, then liquid or solid, ice. Clouds regulate Earth's climate system by carrying moisture and balancing heat energy flow. Condensation continues in clear skies, producing droplets ranging from 10 microns to 1 millimeter. Occurs at higher occurs at higher altitudes where cooler air and barometric pressure promote condensation, reduces air density at high elevation, which allows clouds to form. Sorry. Condensation in real life. You can see condensation in fog, or mist. Um, and number two, wearing glasses. As someone who wears glasses, being in a really cold area or building and then coming outside in a more humid, it fogs up the glasses. Number two, wearing glasses. Oh, sorry. Number three, a cold drink. When the cold drink is being out too long and it's cold, nice, you can see the little droplets coming out outside of the bottom. So sorry. Precipitation. The third process of the water cycle is precipitation. This process is where we get rain, snow, sleet, and hail. Scientifically, water falls from the atmosphere to the Earth's surface in forms such as rain. Precipitation happens after condensation once the clouds are heavy and gravity pulls them as precipitation, which which replenishes Earth's body of water and soil for transpiration. Sorry. Tiny condensed water droplets that are visible despite their small size. I'm really sorry. Evaporation and condensation continues even during precipitation. So even as rain is falling down, evaporation is still happening and condensation is still happening. Droplets might might attract, must attract to particles like dust, salts, or smoke to bind together. Um, Droplets become larger through collision and additional condensation of water vapor. So droplets connects to another droplet, it makes a bigger droplet. Once a droplet are heavy enough to fall faster, the droplets look small and spheric and like round, with a radius under 1 millimeter. Enlarged to 2 to 3 millimeters, raindrops continue to grow at 3 millimeters, and at 4 to 5 millimeters, droplets become unstable and they fall apart. So the bigger they get, the more breakable they're going to be. They're going to, you know, separate. Um, I'm sorry. Um, a method that causes ice crystals to grow rapidly ex- at the expense of the water vapor in a cloud is a more effective way to create precipitation size drop. Because ice crystals are more efficient mechanism, these crystals melt and fall as rain or fall as snow. And this process is named the Bergeron. I'm sorry, I don't know how to pronounce it. Bergeron Finlayson process. Collection. Aside from the three main processes of the water cycle, evaporation, condensation, and precipitation, collection is a part of the water cycle because collection is where water is gathered and is stored in various bodies like oceans, lakes, rivers, and groundwater after precipitation and runoff. Without this step, Earth would not be able to store or reuse water effectively. Surface water from rain and snowmelt, groundwater collects in porous rocks and soil layers called aquifers. Frozen water accumulates as snow and glaciers. System economic ecosystems, which provide habitats for fish, birds, plants, and insects, reduces flooding by absorbing excess water and maintains supply during dry seasons. Runoff is remaining water that did not soak into the ground, and it flows over the land and into streams, rivers, and eventually the ocean. A simple way to explain how runoff works is precipitation fall on land, flows over land, runoff, and runs into water, which empty into land. Runoff does play a major role in the water cycle because it transports water from higher ground to lower areas. Originates from uh, rainfall runoff across the landscape. Small creeks merge with other creeks to larger rivers, then rivers into oceans or a larger body of water. Concrete pavement and hard packed soil increase runoff. Um, Forests, grassland, and gardens decrease runoff because they absorb the water. Steepness of land affects the speed and distance the runoff travels. Runoff can affect the water quality because water that flows through to get to rivers, and it collects pollutants like fertilizer, oil, trash, and chemicals. Although its obstacles, runoff is essential part of the water cycle because it helps more water back into bodies of water where evaporation can begin again. It keeps the water cycle active because without runoff, many areas of the world may not receive the water they need. Infiltration. Infiltration is where some of the water for precipitation gets soaked up into the ground, also known as groundwater, because a portion of the water that falls as rain It infiltrates into subsurface soil and rock. Infiltration does play a key role in storing water beneath the Earth's surface. Sorry. Infiltrated water stays in shallow soil layers. Water can infiltrate deeper, recharging groundwater aquifers stored in porous rock and soil. People drill wells into aquifers to access groundwater. Groundwater may travel long distance, stored for long periods, or seep into oceans. Reduces flooding by allowing water to soak into soil. And stored soil moisture supports plants through transpiration and sustain rivers during dry periods. Different types of soil, sandy soil. Sandy soils allow water to pass through quickly because they have a large space between particles. Clay soils, on the other hand, absorb water slowly due to their tightly packed structure. Loamy soils, which are a mix of sand, silt, and clay, absorb water at a moderate rate. And then we have the human affecting infiltration. We have roads, sidewalks, and buildings because they have surfaces that do not absorb water, which leads to small amounts of water being infiltrated. But these water can go into the runoff section. Now we're going more into the articles. So summer anomalies. The study focuses on the HRB in China, a transitional climate zone between northern and southern China. It is a region situated between the Yellow and the Yangtze River. This area is both economically important and prone to extreme weather, experiencing frequent cycles of drought and flooding. Because of these challenges, the researchers emphasize the importance of studying how moisture moves through the atmosphere in this region, such as how it arrives, how it turns into rainfall, and how much it comes from local versus outside sources to understand the unusual summer rainfall pattern. The water stable isotope. The study the study examines how stable isotopes in river water vary across space to better understand the hydrology of the southern eastern Quai Basin in China. By looking at the hydrogen and oxygen isotopes, researchers can trace river water sources, evaporation, and rivers such as groundwater interaction. Um, this work demonstrates the usefulness of stable isotopes for disentangling complex hydrological processes at both the individual rivers and basin scale. By combining data from multiple rivers, the study provides a more comprehensive view of the hydrological cycle, also known as the water cycle, including evaporation effects, groundwater interaction, and the influence of moisture sources and transport. Climate warming. This study examines the three river source region on the Qinghai Tibetan Plateau, the origin of the Yangtze, Yellow, and Mekong River, which is experiencing rapid warming that is affecting its atmospheric water cycle. Using long-term data from 1979 through 2022, researchers analyzed changes in precipitation, evaporation, water vapor, and moisture transfer, finding that warming has intensified the water cycle, which higher temperatures, increased evaporation, and more atmospheric moisture. In addition, stronger shifts in circulation patterns are altering where the moisture comes from and how it moves. These changes are impacting both the amount and distribution of rainfall, highlighting significant hydrological effects for the region and downstream areas. The conclusion, the water cycle is vital for sustaining life, which processes like evaporation, condensation, the whole cycle of the water cycle. They all work together to regulate Earth's water supply. Um, Often overlooked collection, runoff, and infiltration, they are an essential part of the water cycle because they store and channel water into larger bodies of water, and that can start the process of the evaporation. Studies in China illustrate how climate conditions shape hydrological processes. The Huaihe River Basin reviews how moisture sources drive usually rainfall in drought and flood-prone zone. Isotropic analysis in southern Quai traces interaction between evaporation, groundwater, and river, and research in the three river source regions show how rapid warming intensifies evaporation, moisture transport, and alter rainfall distribution. Together, these findings highlight the critical link between climate, moisture, and water availability across China's major river systems. And these are the sources that I found for it. Um, Thank you. I hope you enjoyed my oral presentation and have a good day.